2. Officially, it's differentiation by tables, graphs, and symbolically. We've already used some tables, yes.
Yeah.
We've already, maybe graphs is a little bit new, but similar idea. Okay, so that might be a little bit new. So I feel like we're on, we're still going to be using things like chain rule. Okay, still going to see product rule, quotient rule, all of that. So there will be times when you need to find an approximation of the derivative. Typically, this type of question will be given in the form of a table of values, and then they don't give you a specific function. So it's not something where you can just plug it in. You have to rely on the table of values. So you'll need to identify an appropriate mathematical rule or procedure based on the given data. So this one, the table gives the values of a function that is differentiable on the interval 0 to 1. Find f prime of 0.1. This one we have to dig back in our memory bank a little bit more than most of the rest of this lesson, but so f prime of 0.1. Notice, what do they give me in the chart? They give me f values. So that's your hint, kind of, that you're going to have to be using f values as we do this. Thoughts of how we could find f prime? What is f prime? It's the derivative. It's also the slope of the tangent line.
So would it be the derivative of 0.261?
But you can't do derivative of just a number.
It would
be like the slope, like y1 minus y2.
Aha, yeah.
Or what I'm going to refer to as AROC.
Oh, yeah.
Okay. I'm going to think in terms of AROC. Now, one thing to notice, they give us a table of values, yes? For us to be able to think like this on the table of values, notice they use the word that this is a function that is differentiable. Differentiable means you can take the derivative. Differentiable also implies, if a function is differentiable, remember it also is guaranteed to be continuous. Okay? If it's differentiable, it is continuous. I mention that because if the values on a table don't represent a continuous function, a lot of what we do doesn't work. So they have to tell you it's continuous in there. So with this in mind, we're trying to specifically find the derivative around 1/10. Well, to do AROC, like y minus y over x minus x, we're going to have two values to subtract. We're going to have to use the information with the 1/10 and 2/10.
Are we using the 2/10 just because it's the closest one?
Yes, because it's the closest one. Because when you do your average rate of change, you want it on the smallest interval possible. The smaller the interval, the more exact the answer is. Okay? So, with that in mind, f prime of 0.1. And in order to do this, I'm going to do f of 0.2 minus f of 0.1, all divided by 0.2 minus 0.1. So basically, it's the slope of the secant line, officially. Okay? Now, I said f of 0.2 minus f of 0.1. Those are your y values, yes? So we're going to be doing 0.433 minus 0.261 over 0.2 minus 0.1. Well, I know the bottom. 0.2 minus 0.1 is 0.1. .172. It's positive minus a smaller number, so it is positive. 0.172 divided by 0.1. What happens when you divide by a 0.1? You move the decimal over, yes? And so we're going to move the decimal over, and this is going to become 1.72.
Yeah.
Okay. So, finding the derivative on the table, use your closest value. So the other option, sometimes if you have values on either side, you might use the values on either side, but using that given value is helpful. Okay, got it? Okay. Example 2, given a table of values. This reminds me of a table we had yesterday, right? There's f, there's g, there's f prime, there's g prime. Find each of the derivatives below of the following at x equals 2. So, here we have h of x is defined to be f of g of x. We're going to plug in 2 eventually, but before we plug in 2, my suggestion, let's write out what's going to be my rule for h prime of x. How much do I need to say here? What do we remember from yesterday? Derivative of the outside, so f prime. When we say derivative of the outside, then the inside is going to stay the same. So f prime of g of x times the derivative of the inside. So times g prime of x. That's old news, yes?
Yeah.
Okay, so now I'm going to go ahead and fill in 2. So is it positive 2? Yeah. H prime of 2 is going to be f prime of g of 2 times g prime of 2. I like to fill in my inside pieces. G of 2 is, what'd you say? G of 2 is 3. And then the other piece, don't let your prime mark get lost. G prime of 2 is -1. So I have f prime of 3 times -1. What's f prime of 3? -2. So -2 times -1 is positive 2. And that is h prime of 2. That's a chain rule, right? When we see a composition, we use a chain rule. We talked about that yesterday. Or day before, one of the two. Okay, what about B? K of x equals f of x quantity cubed. Let's start off writing the rule for k prime of x. Okay. It was something raised to the third power, yes? So apply the power rule. So move the 3 out front, subtract 1 from the exponent. The inside stays the same when you do the power rule. But then the inside, that's something you take the derivative of, so times the derivative of the inside. Whoops. I wrote k prime of x again, but what are we plugging in? K prime of 2. So 3 times f of 2 quantity squared times f prime of 2. Three times f of 2 squared times f prime of 2. You guys at the same point I'm at? Well, I know 3 times 16 in my head is going to be 48. So if I do 48 times 8, did I make any math? Oh, I did make a math mistake. What did I do? Oh, yeah, I didn't add right, did I? 8 times 8 is 64. 4 times 8 is 32. And then I didn't add, I don't know what I did. I only added 2 instead of adding 6. I don't know. So 32 plus 6 is going to be 38. So for 384. Carol's math mistake. Huh? And there's a reason that I kind of like that we start off without calculators, so, you know, because it does force you a little bit to get uncomfortable and not grab the calculator. Don't worry, the calculators are coming back. They'll get there. Okay. P of x is f of x times g of 2x. Now we got product rule. It's kind of a combination. We've got a little bit of everything on this page, don't we? Okay, so product rule. How's product rule work? Okay, so f prime of x times g of 2x. Then this next time it's derivative of the other, keep the other. Now, so I'm going to write it as I'm going to keep f of x and then times the derivative. So g prime of 2x. And then what? We're multiplying by 2 because the derivative of g of something is g prime of something times the derivative of something. The derivative of 2x is 2. There's a lot of stinking 2's. Because we're getting ready to add, what are we finding? P prime of 2. So it's going to be f prime of 2 times g of, should I put g of 2 times 2 or just go ahead and say g of 4? G of 4 plus f of 2 times g prime of 2 times 2, or in other words 4, times 2. Okay, f prime of 2. G of 4 plus f of 2 g prime of 4 times the 2 that's already there. Okay. You guys end up where I ended up? You end up with 16 minus 24. 16 minus 24 is negative 8. And D.
Quotient rule.
Okay. Quotient rule, right? Yep. What is it? High D low minus low D high over high high? No, over low low. Sorry.
That was Moody.
Yeah, you're right. I better just shut up. I just need to be quiet. I'll stick with my way, you stick with your ways. Now, it is quotient rule. What's going to be within here? There's also going to be a chain rule when you see that 2x, yes? Okay. So,
Yes.
I say it as derivative of the top times the bottom. Okay? You do whatever you need to do, right? So derivative of the top is going to be f prime of 2x, which is the derivative of f prime of 2x times the derivative of the inside, so times 2, times the denominator as is. And that's quotient rule, so I'm going to subtract. And now do the opposite, right? So now I'm doing the derivative of the denominator, g prime of x times the numerator all over g of x quantity squared. I don't know how I'm going to all fit this in. Okay. I'm filling in 2's, yes? F prime of 4 times 2 times g of 2 minus g prime of 2 times f of 4 all over g of 2 quantity squared. Hopefully you still have room in yours. I'm just going to work over here. Okay. Are you guys done? F prime of 4 times 2 times g of 2 minus g prime of 2 times f of 4. Oh, that's nice. All over g of 2 squared. Negative 2/3? Because on top you have negative 6 minus 0. So then it's negative 6/9, which reduces to negative 2/3. Okay. Okay. Our last page is finding derivatives from a graph. And by the way, did I really teach anything new here? These are all things that we've already learned, yes? So I feel like this is kind of a practice lesson. I really do. The graph, okay, a little bit new, but it's just we have to gather our information from the graph. That's the only difference here. Okay, so notice up here, h of x is defined to be f of g of x. The graphs of f and g are shown at the right. G is the curvy one. F is the pointy one. Estimate each derivative. Justify your analysis algebraically. Okay. G prime of 3. What are we looking at here? Here's our graph of G, yes. G prime of 3. But it wants G prime.
Oh, the slope.
So G of 3 would be about 5-ish. G prime of 3 wants the slope. Okay? So I even have written in my notes, probably because of, if you're asking G of 3, that's where the 5 is. We need to talk slope now. How am I going to talk slope here? I'm going to draw the
I got it.
tangent line.
Really? I guess.
Okay.
Negative.
What points did you use?
Um,
Or are you just guessing what you think it's going to look like?
it's not- it's gonna-
I'm trying to look and see what points I used. That does not make sense.
You can do more than 4, 3, like
3, 5. I say I have my other line. Well, that doesn't even make sense though. Oh, that's what okay. I have my other point going right here is what I have my other point. I picked 5, 4 to be my other one. So I have mine going through approximately 5, 4 and 3, 5. Keep in mind, their directions were to estimate, yes. So if we use 5, 4, and 3, 5, and by the way, I agreed with Aiden's answer if I didn't say that. Okay, so y minus y, 5 minus 4 over 3 minus 5, or I don't even know why I'm doing that. Can't I just do rise over run? Rise 1, run 2 to the left. Regardless. Negative 1/2. Whether you do a y minus y or whether you do a slope. Or rise or run. Okay, are we good? Okay. F prime of g of 3. Where you need to start? Start on the insides. So F prime of, what is g of 3? Didn't we already talk about that? So now we're doing what? F prime of 5. So F is the other one. F prime of 5. Why not?
Sure.
Okay, so I have written that why did I rewrite that? Okay. I just wrote is a sharp corner or sharp cusp. You know, it's a cusp, a sharp corner, however you want to look at, and so does not exist. Okay? That function is continuous, but not always differentiable.
oh, that equals G.
Okay?
I understand.
So, I'm going to have to bounce back and forth here, but h prime of 3. Up top, what did we know up top? H of x is f of g of x, yes?
Yeah.
Now, could we go ahead and say then that, what's that mean? H prime of x is what? Yeah, I should have probably put this at the top of the page, but yeah. H prime of x is f prime of g of x times g prime of x. We already did that on the back side, really. Okay? So, if we're doing h prime of 3, that means I'm doing f prime of g of 3 times g prime of 3. Okay? Is that the same one we did earlier? G of 3? So g of 3 is 5. What's g prime of 3? Is that we already did that, didn't we? G prime of 3 is negative 1/2. What's f prime of 5?
D and E.
And so What's D&E times -1/2? Does not exist. Okay.
Yeah.
Okay. F prime of 7. We gotta go do something different, don't we? So F. Oh, F is the pointy one, right? F prime of 7. Right, yeah. The slope of the tangent line is this. It's the same thing because it is a straight line. So, yeah, I personally am going to rise over run. Rise 1, run -1/2. So, wrong way. -1/2, and as I said, I would do rise over run there. Okay. Ready for E? G prime of F of 7. F of 7 is 5. I can go with that. So now we're talking about G prime of 5.
Wait a second.
So G, which is my curvy one, of 5. That point right there.
It's about -1/2.
This is a hard one for me to draw. Kind of. Huh? Oh, I thought you were talking about mine's awful. Mine's not great, but it's not horrible. So I think, did I do? I did. So I actually, when I did my slope, I used a decimal point here because I felt like I should use this point here. Like if we're trying to find the derivative at 5, I feel like I should use 5. And that is what? That's 5 over and about 3.5 up. And then there's a couple of other points you could pick. I see 7.2 here. It really kind of looks like I ended up going through 3.5 as well. Actually, those would both work out the same. So really, you could use 7.2 and 3.5 if you wanted. Because if I'm just counting up and over, and they have the same slope between them. So I ended up with 7.2 on there, a 5, 3.5 on there, and what was that other point? 3.5. My original plan was to use the decimal, the middle one, but I ended up with 3 on the same line, so pick 2 and use them. Okay. Should I use the decimal just to be difficult here or no? We'll go the other way. I ended up about -3/4. Okay, one more. H prime of 7.
How did you get -3?
As in this math, or
I got -1.
what points did you use?
5, 3.5, and 7.2.
So you use those two? So 3.5 minus 2 over 5 minus 7. So 1.5 over -2.
Oh, it's 1.5.
Is that where? Okay. And then if you have 1.5 over -2, you can't leave a decimal within a fraction, right? Officially, one way you can always do is multiply by 10, and that will get your decimal out of the way. So multiply by 10 over 10. I see the shortcut though. If I take 1.5 and multiply it by 2, will that get rid of my decimal? So, okay. H prime of 7. So H was the f of g of x, right? So this is going to be f prime g of 7 times g prime of 7. Have we done g of 7? Okay. G is the curvy one. Yuck. Okay. I'm going with this, probably came from her notes. I don't know what you guys were thinking. I was looking at it and thinking maybe it was like 2 3/4. She is 2.8 that she used, I have a feeling. So I have a feeling I took this value. Huh?
I was in that.
Okay.
Are you talking about EC?
It's not me.
No,
I messed up.
I'm right here.
G
I was looking at G of 7.
Oh,
G's on the curvy graph. That was Tate's issue, right?
yeah, 2.8.
So she uses 2.8.
she just kind of guess.
Yeah, it's an estimate. Keep in mind, this whole section is an estimate. Okay? And I can agree with 2.8. As I said, if this is me on my own, I might have gone 2 3/4, just, I don't know. So, f prime of 2.8. What's g prime of 7? Have we done that one? Nope. So, g prime, curvy graph of 7. Maybe?
Not even.
Huh? Yeah. Mine looks like it went through, what, 8-3 and 5-2. So rise 1, run 4. I think if you continue it, probably goes through, what is that, 1. Oh. Huh. Well, I guess we're just going to go different than the answer key on this one. She uses 8-3, but then
What?
she uses 1-1, which it could. This, again, it's an estimate, right? It's an estimate. That's what we just have to go with. So, and it's not going to affect, it doesn't affect anything else other than our final answer. So, if we go with that, are you guys okay with 1/4 then?
Yeah.
Wait, 1/4? No,
Third.
1/3. Sorry. I thought I heard someone say 1/4, so I went. Did you? And again, estimate. Okay. You do you. F prime of 2.8. Last piece. F prime. Ooh, F is the sharp graph. That's nice. 2.8. Right there, ish. Right? Because you're going 2.8. So what's the slope there?
Negative 1.
Yep. No.
Negative 2.
You're upside down. Rise over run.
Right here.
Rise 2, run 1. So negative 2 over 1 times, if I have 1/3, then I'm going to say negative 2/3. Okay, as I said, that different agrees with what she uses as hers, but it's estimates, so. Okay. Work time / questions on